Hi everyone, welcome to part 3 of our discussion about systems of equations with three unknowns. So this time, my first equation, pretty familiar, x plus 2y take z equals 4. Normal would be 1, 2, negative 1. So let's just put, there it is, there's the normal for our first plane, and our first plane is of course perpendicular to the normal. Now equation 2, x take y take 2z equals 3. So the normal 1, negative 1, negative 2. There's the normal. That's good. That normal is definitely in a different direction to normal 1. Plane 1 and plane 2 will not be parallel. They will intersect. Let's see that. Plane 1 and plane 2. They definitely intersect. And as I've previously discussed, we can find the intersection of that line. We can find that line, the equation of that line, the intersection of two planes. So there's plane 1 and plane 2. Very lovely. Let's turn those off for a moment and let's look at equation 3. 3x take 2y plus z equals 1. The normal 3, negative 2, positive 1. There it is. Let's draw that one. And again, it's a different direction to the previous two. It looks like all three of our planes will not be parallel. That's good. We have a consistent set of equations. Now there's the first two, and let's just, why do I still have a normal vector drawn there? I didn't think I had a normal vector being drawn. That's weird. Turn that off. And now here comes equation 3. Equation 3 cuts through both of them, and of course this means we get a line of intersection here between plane 1 and 2. We get a different line of intersection here between plane 1 and plane 3, and a third line of intersection between plane 2 and plane 3. Now in this case it seems like all of those lines come to a single point. Let's turn that point on. So that point there, point A, is the single point where all three planes intersect. Now that's because we have consistent equations and we've ended up with a unique solution. Let's take a look at the augmented matrix, and when I perform reduced row echelon form, there it is. Look at that lovely identity matrix there, and these are our constants. So the unique solution to the system of equations gives me that x equals 5 over 4, y equals 3 over 4, and z equals negative 5 over 4. That's how I knew the values to type there for point A. Now, this is one of the possible outcomes when we have a system of three equations. A consistent set of equations producing a unique solution, and all three planes obviously are and in different directions, and that's why we get that unique solution. Thanks for watching.